Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this couple of videos we are going to take a detour from pandas and talk about basic descriptive statistics. And the reason for this is that in coming videos, when we start using some of these statistical methods in the code, you'll be able to interpret what the output is, and you'll have an intuition about what's probably happening in the background when the code ran to give you that particular output. So here in this couple of videos, we're going to talk about all these topics that are put here on this slide, starting with what is population and sample in statistics, and then what is histogram, mean, standard deviation, all the way up to geometric mean and harmonic mean. So there's a lot of stuff in here, and I tried to make one video, but it was more than an hour, so I've broken that up into multiple videos, and in each of those videos you'll see parts of this being discussed. So I hope you learn from these videos. So let's get started. Let's look at ranks, and you're probably familiar with what rank means. So you order a certain observations and then rank either from highest to lowest or lowest to highest. The same analogy would apply here. We have these 7 data points, we sort them in ascending order and put them in this column on the table on the right hand side, as we see here. So here I'm going to explain 4 types of ranks. The first one is average. The way this works is 11 is the smallest one, so in this case we are ranking it as 1, and then there are 234s, so this would have been 2 and this would have been 3. However, in case of average, we are going to take an average of 2 and 3, which is 2.5, and assign 2.5 as a rank to both of the 34s that we have. And after that we skip the rank 3 completely and move on to 4, 5, 6, 7, as we see here. In case of minimum, what we are going to do is start with 1 for 11, which is the lowest one, and then again, because 34 is repeating, it would have had a rank of 2 and 3. However, because this is minimum, we are going to pick the minimum of 2 and 3, which is 2, and assign the value of 2 to both the 34s that we have right here, and skip 3 entirely, and then continue adding ranks from 4, 5, 6, 7 for the rest of the observations. For maximum, it's same as minimum, except we are going to pick the highest. So because the 34 would have had a value of a rank of 2 and 3, we are going to pick maximum, which is 3, and assign it to both the 34s, and completely ignore 2 and move on to rank other values starting at 4 and then 5, 6, 7. The dense rank, on the other hand, works differently. Here we start at 1 for 11. Now for the 34, although it could have had values of 2 and 3, we assign it a value of 2 for both of them, and then we do not skip the number rank 3. We assign the rank 3 to the observation after the group of 34. So in this case, we assign the rank of 3 to value of 40, and then move on from there. So 4, 5, 6 for 55, 67 and 94. So that's how the rank works. Next, let's look at percent and percent change. You're probably already familiar with this, but this could be a rehash. So here we have the same observations. I've put them in the table on the right hand side in the first column for battery life, and for at the bottom of the first column there is a total, which is 335. So that's the total battery life that we have measured for all these 7 laptops, 335. So let's say if you want to find out what percent is the battery life 11 for the first laptop from all those that were measured. So to do that, you would divide 11 by the total 335 and multiply it by 100, so you get 3.28. So 11 is 3.28% of 335, which is the total of all battery lives that were measured. Similarly, you can go ahead and calculate that for 34. So 34 divided by 335 into 100 gives 10.14, and that's around 10%. So 34 is 10% of 335. That's how we would calculate percentage. Now, one point to remember here is that after you calculate the percentages for all the observations, when you add them up, they should add up to 100. And if they do not add up to 100, you probably want to go back and check your calculations. And that's that's a check I've used routinely during analysis. So if it does not add up, it means there is some mistake somewhere. The reason why it is off by 0.04, it's 99.96. It's because I've rounded off the floats after the decimals, and that's why it's not exactly 100. But in your project, if you add them up for similar percentage calculations, and if it adds up to just 95, then that 5% difference is a very big difference that points to a possible mistake. Next, let's look at percentage change. Again, we have those same 7 laptops we have measured battery life for. We put them in this first column, battery life, and here what we intend to find is how did the percentage change from laptop 1 to 2 to 3 to 4 and so on. And to do that, what we are going to do in column 2 is calculate the change first. So 11, in this case 34 minus 11 is 23. So the change in the battery life in minutes was 23 between the first and the second laptop. Between the second and the third, both had battery life of 34 minutes, and so the difference is 0. However, if you go from the third laptop to fourth laptop, the battery life went from 34 to 40, and thus there is a difference of, or a change of 6 minutes. Now, how do you put that in percentages? Do that, what you do is 100 into the change that was there, so in this case 23, divided by the previous value, which in this case was 11. So as you can see that the battery life from laptop 1 to laptop 2, as it went from 11 to 34, there was almost 200% increase in the battery life measurement. And battery life that we measured, again, as we went from laptop 3 to 4, there was about 17% increase in battery life that we measured. Now let's look at cumulative sum, cumulative product, cumulative minimum, and cumulative maximum. In case of sum, we again have the same experiment. We measured the battery life for 7 laptops. We have these readings and we sort them in ascending order, put them in this data set on the table on the right hand side, and we now want to calculate the cumulative sum. So what cumulative here means is we are going to perform the sum row by row by row, and we are going to carry on the sum from each row to the next row. So we are going to keep adding to the previous sum. Here we have 11, which is the first value, so that stays as is. Then the second value is 34, so we are going to now take this 11, add it to this 34, and then put that here. So we have 45. Now add this 45 to this 34 and put that here, so you have 79. Next we are going to add this 79 with 40 and put that here, which is 119, and thus this column is created, which is the cumulative sum. And this cumulative sum is helpful in analysis where you want to, let's say you want to plot a cumulative increase in let's say yield of a particular crop over the year. Then what you do is add the growth of those plants in each of the months, and then by 12th observation you have a nice cumulative plot or curve that increases, that shows the cumulative increase or growth of that particular plant. Similar to sum, we can also use cumulative product. It's exactly the same method. We have these 7 observations which are put here, and then the first observation 11 stays as is. Now instead of adding, in this case we are going to multiply. So 11 multiplied by 34, we get 374, and 374 multiplied by 34, we get 12716. Again we multiply this by 40, we get this value, and so on and so forth. So this is cumulative product. Cumulative minimum, we run the same experiment. We have measured the battery life of 7 laptops, and we have these readings 11 through 94. We sort them in ascending order, put them in the table on right hand side in the first column, and then to calculate the cumulative minimum, we are going to find the minimum between two values that we have. So 11 stays as is because there is no value above 11. Now for the next, we are going to take this 11 and take this 34 and take the minimum of those two. So the minimum of this 34 and 11 is again 11, so we put 11 here. Next, the minimum between this 11 and this 34 is 11, so we put that here. The minimum between this 11 and this 40 is 11, and that's why I put it here, and so on and so forth. So the cumulative minimum for this entire data set is 11. Cumulative maximum is similar to the cumulative minimum, except that we are going to pick the maximum value. 11 stays as is because there is no value above 11. Next, we are going to take this 11 and take this 34 and pick the maximum. So the maximum is 34, and therefore we put the 34 here. Next, we compare this 34 and 34, pick the maximum, it's 34, put that here. Again, comparing 34 with 40, and then pick the maximum. So maximum would be 40 in this case, and therefore we put that here, and so on and so forth. So this is how you would get the cumulative maximum. That was it for this video. In next video, we'll continue learning more about statistics. Please like, share and subscribe. Thank you.